This presentation is based on preliminary studies from two of my master's students, Ariel Jenkins and Holly Hefner at University of Louisiana at Lafayette. Ariel is working on Chicago parks that can potentially can be used for urban agriculture. We will fund it by USDA NRCS grant for it. And we're also writing, she's working on a review paper for XRF method that can be best used for urban agriculture. So there's more coming about XRF. And Holly on the left, she's working on Lafayette, mapping entire city of Lafayette. But for this particular presentation, we will only present the parks. So here's the Lafayette, Louisiana. You can get an idea where Louisiana, Lafayette parish is located. We collected about 1,000 samples so far in the city. And for the park specifically, she analyzed 200 samples. They're mostly for potential human exposure. So we collect about 2 inches and we follow Dr. Milky's method to further map Lafayette. Actually, I have a LED map here for census tract. So we will have at least 19 samples for each sample location, but we will have more. And this interesting work because yesterday we talked about XRF and community engagement. And this project in Lafayette really became a community project because you can access someone's home unless you have permission to do that. So we will have to reach out to local government, Lafayette consolidated government, to connect us to neighborhood leaders, to talk to their members and let us in into their properties. And I ended up going to some of the neighborhood meetings, talking to residents, and we get like really great feedback from people. They want to know what's in their soil. They don't think about heavy metals. And we even were published recently in local newspaper and in the channel interview on local TV channel to bring more attention to this issue and get more samples from people. So that's for those who work with communities, it's a great way to do this is to reach out to local governments and work with them. And of course, we get a lot of help from USDA NRCS. So for this particular project, I asked Holly to pick just parks and get an idea what we would get concentrations wise for heavy metals. We'll have multiple heavy metal data and we will calculate in the pollution indexes. But for this presentation, just picked lead. And you can see that again, inner city, even looking at the lead, concentration is higher in the downtown area, center area, it's more historical, and it disperses as we go further with less people. So this measured lead in multiple metals, but lead in particular in 5 different parks, 200 samples. What we found that concentration you can see is very low. This is y-axis here is 100 parts per million, and only couple of the outliers were here. Most of the samples way below 50 parts per million. They were on average about 20 ppm for lead, which is natural background, which is great because in Louisiana they do a lot of festivals and all these parks are engaged in huge festival activities. It's people constantly have concerts, eat, having picnics there. So it's really important to test parks and see what we get. So in terms of lead, it was great. In terms of arsenic, we saw some high concentrations, about higher than 12 ppm, which is Louisiana guideline. But arsenic is also naturally found in Louisiana soils because it's a sediment that's brought down by Mississippi. So it's likely this arsenic is not due to contamination, but transport by sediment. So in the Chicago parks, these are quite interesting samples, and we will continue talking with James Montgomery, who promised to help on this and figure out the solution, what we can do with these areas and these parks. So this summer, we went to Chicago to collect samples because we had the grant from USDA to analyze samples from 2 different cities. We did Chicago, and next one will be St. Louis in collaboration with local NRCS. So we went to 5 parks, and it was an interesting experience. For my students, it was first time flying on a plane, and we had to take Ubers everywhere and with lots of bags and carry all the samples. So people give us looks like, "What are you doing?" And a lot of people approach us in the parks like, "What are you doing?" But everything was great. We had multiple samples from very large parks like Humboldt Park to or Grand Park to small parks. So we kind of wanted to see the distribution between different scale of parks. Of course, Chicago has a huge park system, and the city itself is really big. So we'll contribute to the existing soil survey and perhaps James' project that he mentioned earlier, so we can be part of larger database and see what results we're getting. But the idea for this particular project was to see if these parks can be used potentially for urban agriculture purposes. And in some areas, like in Grand Park, we did see some urban ag sites, and it was really great to see the sustainable practices. They were doing mulch. It was really beautifully decorated, and people do growing some collards. So I think we need more of this, but we need to make sure its soil is not contaminated. And we collected soils in the topsoil, 15 centimeters. So it was more work a little bit than do it at sample in Lafayette, because it was June in Chicago and it's super dry soils. So, but we had some fun. So what did we found? I'll just highlight a couple maps to show you how the sites we picked. We picked the sites in these 5 different parks I have here to show you, from particular areas of the park that we thought could be used for agriculture, because not every open space in the park can be used for ag, because it can be baseball field, maybe it's a place area for cafe, or it's in a hill or something else. So this area that we choose, we're looking like it was sunny enough, not many trees, and a flat area that could be used for gardening. And here concentrations were more interesting. We see clearly that concentrations in Chicago parks were much higher for lead compared to Lafayette samples. There were some of them, we had several outliers in Douglas Park, more than 400 parts per million, which is the EPA guideline for children playing in bare soil. But most of soils exceeded more than 100 parts per million of lead. So you can see some of the, here's more like yellow orange colors, but the Douglas, there's some quite a few of dark spots, more than 400 parts per million. But what's also interesting to do to see in these parks is the heterogeneity. One corner here is less than 50 parts per million, and the other side is much higher concentration. So even in one park, we see this heterogeneity, because there are lots of, I guess, influences from facilities that are around. And arsenic, this was quite interesting to correlate. There are some areas where we could see both lead and arsenic higher. Douglas Park again had much higher concentration. And last night I looked up the guideline for arsenic in Illinois. And if anyone knows what is arsenic concentration guideline, I found it 75 for Illinois. So I wanted to, I wanted to put the line here, but I was like, I better confirm this someone in the know. In Louisiana, it's 12. In New York, it's 16. So yeah, so it's super high. And yeah, each state has its own guideline. If we consider 12 ppm as a guideline, you can envision here the line that again, a lot of samples this. And it's a question where this arsenic is coming from. So maybe some of you know work in Chicago. We were researching last night, and potentially maybe it came from the sediment, or maybe there's some used with lead arsenate, because it seems like, especially in the Douglas Park, both of them lead and arsenic concentration. So this is something we're going to investigate more, and again, it's a preliminary result. Since we talk about XRF, we analyzed these samples. We brought them, collected them in Chicago, collected in Lafayette, and analyzed them in the lab. We know that PXRF can be used in the field, demonstrated during our trip and workshop yesterday, but I wanted to highlight some best practices if you're doing it in the lab. Anyone is using XRF? Okay, a few of you. So for those who are going to use it in the near future, think of the best practices you can use to increase your accuracy of the results. Think of a container that you're using. We can measure heavy metals in soil in plug bags, but the best way is to use these XRF cups with the XRF film. This film is the best one. It's a 4 micrometers proline film, and it's commonly used because it has no impurities in it. So it's developed specifically for these measurements. Ziploc bags may contain some impurities in it, but it depends on what grade of research you want to do it. If it's for screening purposes, ziplocs are fine. But if you do something more accurate, more precise results, you should use a film. Use plastic containers. They're better than metal ones. And better than Ziploc bags. Use standard reference materials. This is just example of a one, but there are multiple ones depending on what you're doing, sediment, soil, or maybe plant tissues. There are multiple standards you can buy to build your external calibration curve. XRF typically have a calibration that's already installed in analyzer itself, but you can use your own external standards. Then you want to think about exposure time, how long you measure in your sample for. Found in literature that's at least 60 seconds. In my labs, we always did 90 seconds. No difference after 90 seconds what to do. So 60 to 90 seconds is a good. Samples should be homogenized. If there's some like pore space or gravel or pieces of branches of plants, it will disturb the readings. XRF sample needs to be at least 1 centimeter, but it penetrates only about 2 millimeters. So the sample needs to, and it's about 1 centimeter in radius, like minus. So you need to make sure that surface is clean. Moisture is problematic if you have more than 10% moisture in the sample. That's why it's important to at least air dry the sample, but we typically oven dry the sample for 24 hours, 105 degrees Celsius. We sieve it, we crush it and sieve it under 2 millimeters and then analyze ref cups or maybe like a small plastic bags, but we test them to make sure there's no impurities. And if you do measure samples in bag, especially if it's in the field or in a workshop, do it 2-3 times to get an average, because each site will have a different concentration. So get an average. So we actually recently with Maxine published a paper that I encourage you to use your QR code. And if you don't want to buy it, you can email me and I will send you a copy. But this is a really great resource for management of parks, sport fields, and schoolyards. And it combines, you see, the best management practice with some current examples from urban environments. If we find contamination, what can we do? There are multiple ways, and some of them were presented and will be talked later. But overall, we have in situ and ex situ techniques that we can use to change the chemistry of the contaminants. We can encapsulate it if the contamination is very high. We can use a soil flushing if to inject extraction fluid into the soil. We can use the different immobilizers to create these contaminants. We can use phytoremediation, as someone previously offered trees for jacket joiner. And of course, we can use compost and mulch. There's something anyone can do. If you don't want to read that big paper, I have another guide that I recently created for sustainable soil management. So you can also use a QR code to download. And I want to brag to you that I'm publishing my urban soil guide, and it's coming out in early next year, published by Springer. So importance of networking. Came from here. Springer reached out to me last year during Triple SA meeting, and I said, if I have anything else I want to publish with them, I said, yes, I gave them hard copy. Bring a hard copy with you everywhere. And it's like, want that. So go to talk to those people. And the key point, soils are heterogeneous. Urban soil testing is important. We have ways to remediate the soil, and XRF is a great tool to measure this contamination. I would like to thank my students, of course, partner organizations, funding agencies, and thank you very much for your attention.